Welcome to benchmark 16. We're jumping ahead a little bit here in the benchmark numbering so that we can do inequalities. If you remember inequalities, we have greater than, less than, greater than or equal to, and less than or equal to. In all of these cases, the wide end will point to the bigger side, and the pointy end points to the smaller side. So whichever way it's facing, you want the greater side to point to the bigger number and the smaller side to point to the smaller number. There are other ways of using these words as well. So the last two, where it says greater than or equal to, you can also call that no less than. Because if x is greater than or equal to 5, that also means x is no less than 5. X can be 6 or 7 or 8 or 9 or 10. X can even be 5, but it can be no less than 5. So those two statements, greater than or equal to, is the same as no less than. In the same way, less than or equal to means the same thing as no more than. If I say that x is less than or equal to 4, that also means that x can be no more than 4. It can be 4 or 3 or 2 or 1, but it cannot be any more than 4. So how do we graph these on a number line? Let's start with the example x is greater than 7. I'm going to put 7 right in the middle of my number line because I know that I'm going to have to put some kind of mark there. Because it does not include 7, I'm going to draw an empty circle, and then I'm going to decide, does the arrow go to the left or to the right? Well, 8 is greater than 7, and 9 is greater than 7, so I'm going to color in all the areas to the right, and I'm going to color in the arrow itself, because it shows that it goes on forever. And this empty circle means that it does not include 7. It says it has to be greater than 7. But what if x is greater than or equal to 7? Well, then what I'm going to do is I'm going to fill in that dot as solid as I can make it, because this time x can be 7. It's still greater than or equal to, so the arrow and the line still go to the right all the way to infinity. So if I have x is greater than 7, then I have an open circle because it does not touch 7. If I have x is greater than or equal to 7, then I have a closed dot because it does include 7. Less than and less than or equal to work exactly the same way. We're going to put a 4 in the middle of our line and then add at least 2 numbers on each side so we know which way the number line goes. And for less than 4, we know that it does not include the number 4, so we can't put a solid circle. We have to circle around 4 and go in the less than direction. We're pointing to the left. And if you'll notice, the arrow looks a lot like the less than sign. As long as you keep your variable h or x or whatever letter it is on the left-hand side, the arrow will match the sign. For h is less than or equal to 4, this time we fill in the dot on 4 because h could be 4. And once again, we color all over our line all the way and include the arrow. When we get a problem with a simple addition or subtraction, we approach it the same way we did with our equations with an equal sign. We need to get r all by itself on the left-hand side. That means we need to subtract 2 from both sides. We end up with r is less than -7. So we put -7 in the middle. Remember, in negatives, it goes bigger towards the left. Now is that a greater than, less than, greater than or equal to, less than or equal to? This time it's a less than, and it matches the arrow on the left. Does it include 7? -7? No, it does not. So we put an empty circle around -7. So what do we do with division? To get rid of that 2 on the bottom, we're going to have to multiply both sides by 2. We know that these 2's cancel each other out because 2 over 2 is just 1. 6 times 2 equals 12. So we're left with k is greater than or equal to 12. So we'll go ahead and put 12 right in the middle. Put at least 2 numbers on each side. And then we have to decide, do we put in an empty circle or a full circle? Well, k can equal 12 in this case, so we'll put a full circle right on 12. Fill in the line to the right and match the arrow with the greater than or equal to sign. So here we've got a situation which is different than any of the ones we've seen before. We have a -3 on the left-hand side multiplied by our variable y. When we multiply or divide both sides by a negative number, we're going to have to remember to switch the sign. So in this case, we're going to try dividing both sides by -3. So on the right-hand side, we have 12 divided by -3, which gives us -4. On the left-hand side, we have -3 divided by -3, which is just 1, so it just cancels out. So we're left with a y on the left side. But what we have to do is take the less than and make it into a greater than. Let's plug in some examples to make sure that this works. So I divided both sides by -3, and I got y is greater than -4. So these two inequalities should be the same. If I plug in y equals 0, on the right-hand side, I get 0 is greater than -4. Is that true? Yes, it is. On this side, I get -3 times 0 is less than 12. -3 times 0 is just 0 is less than 12. That's also true. What if I plug in -5? On the right-hand side, I get -5 is greater than -4. That's not true. On the left-hand side, I get -3 times -5 is less than 12. A negative times a negative is a positive, so I end up with 15 is less than 12. That's also not true. Let's try one more. Let's say y equals -3. If y equals -3, on the right-hand side, I'll get -3 is greater than -4. That's true. On the left-hand side, I get -3 times -3 is less than 12. Again, a negative times a negative is a positive, so I get 9 is less than 12. That's also true. So what we're learning is that when I have a negative on the left-hand side multiplied by our variable, and I need to get rid of it, I'm going to have to flip that sign around. Once the variable's by itself, we're going to use our new inequality for the number line. We're going to put that -4 right in the middle, add a couple numbers on each side, and we see that it is greater than, so we're going to need an empty circle around it, and it goes to the right to match the arrow on the right-hand side, and we're going to fill in our line and our arrow to the right. We're going to try another example where I just have -y is less than or equal to -2. Now, as we learned in the last lesson, if I multiply or divide by a negative number, then I have to flip that sign around. So if I divide by -1 or multiply by -1 here, I'm going to end up with just y is greater than or equal to 2. So how did I get that? I took -y and I multiplied it by -1, and I took -2 and I also multiplied it by -1, but because they were negative numbers, I had to remember to flip that sign the other way around. So let's try plugging in some examples just to make sure. If I plug in 3 for y, then on the left-hand side, I'll get -3 is less than or equal to -2. Is that correct? Yes, it is. If I go on the right-hand side and plug in the same number 3 for y, I get 3 is greater than or equal to 2. Is that correct? Yes, it is, because they're the same inequality. Let's try drawing it on a number line. We're going to use this one because it has y by itself without the negative sign in front of it on the left-hand side. We're going to put 2 right in the middle, and we're going to add at least 2 numbers on each side of it. Now we know that it's greater than or equal to 2, so we put in a solid dot, and we draw the arrow greater than all the way to infinity. And checking with the number we plugged in, 3 is greater than or equal to 2. Take a minute to really look at this and understand that if I have a negative sign in front of the variable, when I divide or multiply by a negative number to get it by itself, that sign has to be flipped around. The last type of example we're going to look at is when the variable's on the right side. We always want to try to get the variable on the left side in inequalities, so that we can say the variable x or n or whatever it is greater than or less than something else. We never want to say 12 is greater than n. What we want to say is n is less than 12. Do you notice what happened there? When we switched the 12 and the n, we also had to switch the direction of the greater than sign. If you look in the first inequality, you'll see that n is at the tiny little point of the triangle, and the 12 is at the spread open part. When we flip it around, it has to stay the same way. So 12 is greater than n is exactly the same thing as saying n is less than 12. These are equivalent statements, but because this has the variable on the left side, we like that a lot more. So another example could be 2 is less than n plus 2. Well, we have to subtract 2 from both sides. We end up with n is greater than 0. See how I wrote that backwards? That was to try to help you realize that when we put n onto the left side and the 0 on the right, we need to flip that sign around again. So 0 is less than n is the same thing as saying n is greater than 0. So we've just got 4 main points to remember. First, the big side of the greater than triangle is the greater side, and the small pointy side is the less than or smaller side. So x is greater than 7. This big fat side right there, that is the greater than side. That point at that side, that's the less than. So x has to be greater than 7. And 7 is less than x. Number 2, always try to get the variable on the left side. So if we have 3 is less than x, we want to flip the 3 and the x around. But remember, when we do that, we also have to flip the direction of the less than sign. So if we flip everything around, 3 less than x is the same as saying x is greater than 3. And because of that, if the variable switches sides, so does the sign. And finally, don't forget that if you multiply or divide both sides by a negative number, the sign flips around. So if we have negative 2x is greater than or equal to 4, if we divide both sides by negative 2, the negative 2's will cancel out on this side, and we'll be left with x, but we have to flip the sign around before making it less than or equal to negative 2. If you remember these 4 rules, you'll be in great shape.